I'm just going to show how to boost electricity a little bit. So if you've got a 1.5 volt AAA battery here, and you have a 3 volt LED here, you can't light this with this much voltage. You need more voltage. Let me show you that. I'm going to get some wires out.
That's what that is.
Right.
It's got that on one end. Costs about 10 cents. Apparently, you cannot boost it with a AAA battery. So he's going to accelerate the process.
I'm going to make it work. I'm going to use just some magnets that are not doing anything but holding the wires in place. There's no magnet magic going on here. It's just to allow me to stick things together conveniently. Let me attach one lead there. I'm just connecting these to the battery. So I have a connection to the battery, and I'll show you that I cannot light this. I've got these 2 wires connected to this battery. They're not going to be able to light this LED no matter which way I hook this. It's not going to work. Okay? I'm going to try it both directions just to show you. This will not light.
Okay, what's the point of showing it will not light?
I'm going to show it another way in a minute. I tried it both ways, and you see I've got a connection from the battery through the LED. It's not enough volts. However, if I take this wire...
Is there any voltage at all going through this yellow cord, black cord thing?
Well, it would...
A very minimal amount?
There's only a power flowing if this connection is made between these two.
So if you connect
So if the positive is not connected to the negative, if I connected these, I would be shorting this battery because there's no real resistance. It would just be, destroying the battery very quickly.
Okay.
If I place a load between these two, it will try to send power between them. However, this type of lighting is called an LED, a light-emitting diode, and a diode is a one-way valve. It only allows power to flow in one direction and not the other direction. So if I place it in the opposite direction, no power will flow. If I place it in the correct direction, power will flow if there is sufficient voltage, which has to be 3 volts for this LED. And since this is only 1.5 volts, no power will flow in either direction, at least not without boosting that. In order to boost it, I'm using a little coil, and this coil is nothing more than wire, paper, and tape. Anybody can make this. A 10-year-old can make this. It's just a piece of calculator paper that's stretched out to about 5 feet, folded in like a W, and then wire taped in the inner seams of the W, and then folded over again, and then rolled up, and then tape holding that all together. That's all there is to that. That's about 10 feet of wire altogether because there's 5 feet each direction. And those two are connected so that the inside of one spiral is connected to the outside of the other spiral. The inside of one wire is here, the outside of the other wire is here.
Okay.
And the intersection of the two, that is the inside of one and the outside of the other, are connected right here. So you can see that goes both directions.
Got it.
And so the energy will spiral in from this side, and it will spiral out the other way. It opposes in each direction the magnetic field, so that creates a capacitance effect, which is not traditional inductance. The inductance is canceled. And this is a Tesla bipolar pancake coil. Nikola Tesla invented this.
Nikola Tesla invented this gizmo that Mike just showed us. Nikola Tesla is known for...
He invented alternating current, which we all rely upon for our traditional energy today. But he went beyond that, and he developed impulse power and other types of power that we can build on from here. The problem is that there was an investment that had been made in alternating current at that point, and there was no real desire for industry to reinvest in the impulse and really broadcast energy technologies that he had come to, where it really would be impractical even to have to meter it. It was so abundant. And how do you really maintain a power hierarchy if power is free?
There's a car called a Tesla, I believe?
Yeah, well, there's a car that's using that brand name, but that's not related to Tesla, the person, the inventor, who gave us alternating current, who gave us impulse currents.
Really?
Yes.
I thought it was in honor of him.
It's in honor of him, yes, but it's not related to him as a person.
Yeah, Nikola Tesla is now, after his death, of course, now we are coming to understand how valuable he was. And he created this little coil that Mike is going to show this process.
Right. So I'm actually going to go beyond what I just said I wanted to do of lighting this light. I'm going to actually light 2 LEDs. So I have a second LED, and I'm going to light them in series. What that means is that the power has to pass from the one to the other, not together in parallel. And that means you need 6 volts to go across, not just 3.
Okay.
So it's kind of doubling my demand here. But I'm going to do that. I need a transistor, and the transistor is something that Tesla did not have. He had to make do with spark gaps. So if you look at Tesla coils and how those function, they function in the way that I'm going to show, but they use a much louder, more difficult to work with device called a spark gap.
So does it make a zapping noise and stuff?
Yeah, those make a zapping noise because they literally are passing a spark in the air. And in some cases you can seal them in a vacuum, or you can quench them with magnets, and there's all kinds of other things that you can do that he did to manage all of that. But the transistor was not something that existed when he was around. Yeah. So this is something we have the advantage of today, that we can build these kinds of devices with nothing more than a transistor. This costs about 3 cents, maybe, if that. You can get 100 of them for $3. We're taking electricity and we're making it more efficient. We're going to generate impulse, but we're using a DC input from a battery, and that battery is giving us 1.5 volts of DC. But the other thing that I've got on this is a resistor, and that's connected to the base of this transistor, and that's a 1K resistor. And the reason for that is to limit the current that's flowing to the base, and the transistor will allow about 100 times more current to go from the collector to the emitter over here if there's current on this base. And when the current is turned off to this base, then the transistor will become a stopped valve, basically, and will allow the current to flow in the opposite direction on the coil. Mm-hmm. And when that happens, it's going to flow out through these LEDs. Okay. And when it flows out through these LEDs, you will see they will light up, and they will light up brightly if I have all my connections correctly. So I need a few more things to hook up here. Let me do this. I need to hook up this LED to this. And I'm going to connect this LED to this center part of this coil. And I'm going to connect the base, the opposite end of this, to the base of the resistor. So we've got 2 routes out of the coil through the base to turn it on and off, and then it'll go out through here, and then the other side is going to come from the emitter. And I'm going to jump, as I said, from this one here to this one here. And then I'm going to connect these together at this center point. And they turned on. You see? So they're both lit.
Let me get them both in. See that? So, I'm assuming all you guys are paying attention here, and through this demonstration, you'll be able to go out and do this yourself. And under what circumstances is it convenient to know how to do that?
You should always know how to do this.
Why?
It's just like knowing how to do basic things. How to turn on a light. It's kind of basic. This is how to turn on a light.
Well, but we got switches in our walls.
Yeah, but those are running the wrong kind of power. It's like pushing a swing, right? If you want to push a swing, you don't wind the swing all the way around. You push it when it comes to the base.
Okay.
And if you want a swing to swing all the way around, you still do that at the right frequency.
Right.
And that's how this kind of a circuit functions. It provides an impulse at a timed interval that pushes the swing and allows inertia to carry the swing around and allows gravity to bring the swing down. And so that inertia and that gravity is free energy of your environment.